Hello. In this video, we're going to let d of x equal the square root of x plus 3 and a of x equal x minus 5. We want to find the following. A composed of d of x. Okay, so in this question, we're going to let that become a of d of x. Working from the inside out, replace the d of x with what we see it is. In this case, d of x is the square root of x plus 3. So this is really asking us what is a of the square root of x plus 3. Excellent. And what we're going to do is we're going to replace the x's in the a function now with whatever's in parentheses here. In this case, the square root of x plus 3. So this is going to go ahead and give us the square root of x plus 3 and then minus 5 outside the parentheses. Be very careful to make sure that that is outside the parentheses. If you do something like this, it would be wrong because you can't really tell if that minus 5 is inside or outside the radical, so be careful. Make sure that it's very clear that it's outside the radical, and please don't be sarcastic. Don't do that. You know, I've had some people do that in the past. Don't be sarcastic. Only I'm allowed to be sarcastic. Okay, that's not true. Anyway, that tells me that a composed of d of x is equal to, well, just this. The square root of x plus 3 minus 5. And that's it. It really is. And just a reminder, we saw from the previous video that d composed of a of x is equal to the square root of x minus 2. I hope you're starting to see that it's really hard to get a composed of d and d composed of a to be the same thing. So in this case, notice that they're not the same thing. Once we start seeing functions where they are the same thing, they actually have a very particular name, and they're very important to us. And you'll see why later on. Alrighty, well, I believe that's it for this particular video. I'll go ahead and end it here, and I will see you in the next one. Have fun.